check 1, 2.
It's karaoke. I don't like this.
What, the wire?
No, I've never done it like this.
Oh, okay.
Oh, no. All right. Hello. Am I too loud there? Hi, everybody. Students, why don't you come, I don't know, fill out the bleacher area over here. Come on. You can't hear me? It's too echoey. It's okay?
Yeah, go ahead.
All right, well, I wanted to thank everybody for coming in today. I'm really excited to show you guys what our students have been working on. I know this year's been a little different, but we are really, really excited to show off what our students have been working on throughout the past, pretty much the entire school year. You know, this whole process started in the fall, designing and coming up with ideas for these robots. And then the spring semester, so the past, 16 weeks or so, students have been busy manufacturing the robots that are here in front of you today. So, like I said, let's give it to our students and mentors here for all the hard work they've been doing this school year. By the way, for all the newer parents here, my name is Mr. Wong. I know I haven't met a lot of you yet, in person yet, but thank you guys for coming in today. This is Mr. Strzelecki. He's one of the other teachers with us. Mr. Bernardi, I saw him. He's over there in the audience. And then Mr. Kasea and Ms. Sheehy, which are out in the front over there, helping us out. But anyways, thank you guys for coming in. I am going to give this to Mr. Strzelecki to talk about what's going on today.
Hello, everybody. So today you're going to see a series of matches between robots. And in between those matches, you're going to see, or you're actually going to meet the robot. You're going to actually meet the team that created the robot. They're going to explain their process in manufacturing, what they put together. You're also going to see some pictures throughout the year. And you're also going to see, the FRC at-home challenges and and the awards that went into that. So you're going to see a number of different things in between matches. And I was also told to make sure that in between matches, like if you need to go to the restroom, if you go out the door to the left, they're both on the left. Okay, so if you need the bathroom at any point, that is where they are. I'm going to turn the mic over to Billy, who is going to explain the Fuel Duel setup and the rules, and he's also going to be your play-by-play announcer. So, Billy?
Hey everyone, I'm Billy. I'll be going over some of the Fuel Duel rules for today. So you can see we've got our nice large field here set up with a whole host of fuel cells. We have a total of 111 of these, and throughout the course of our 2-minute and 30-second match, robots are going to be competing for taking as many of them as possible and placing them in their drop-off zones on either side of the field. Like many normal first games, we have a 15-second autonomous period where the robots are also going to be trying to knock the black and white fuel off of their posts for bonus points. And also the winner, or the team that has the most points at the end of the autonomous period, gets a bonus added to their score at the end of the match. Once autonomous is over, drivers are going to pick up their controls and play the game more or less the same way, with the addition of being able to take fuel from their opponent's goal and bring it towards their own. Once the timer hits 0, all the points are tallied, and whoever has the most points, including bonuses from autonomous, is going to be the winner of the game. That's more or less it. Fairly straightforward game, one-on-one. Everyone knows the rules here. Good luck to the teams, and I'll pass it on to no one. All right, and we're out ready to get started with our first match. So over here on the Red Alliance, we're going to have Team 111B, and in blue, we've got 111C. So when we've got the thumbs up from the field, we'll have drivers behind the lines. All right, drivers behind the lines, and 3, 2, 4, and we're off. Both robots moving in autonomous, 111C approaching their black goal, and 111B successfully knocking off the black fuel. That's the end of autonomous. Teams are paused while we get ready. Pick up the controllers. And we're off. Teleoperated mode has now begun. Drivers are in full control of the robots. 111B quickly dropping off their black fuel in their scoring zone for 25 points. 111C looking to knock their black fuel cell off, and it's gone. Meanwhile, 111B attacking the middle of the field, collecting as many of the yellow fuel cells as they can. B looking to knock off the white fuel cell from the opposite side of the field. They get it done, and they're going to deploy into their scoring zone. C gets the white fuel off their opposite goal, collected. while they're over here, getting as much fuel as they can to bring to the other side. Looks like there's an attempt made to steal that black fuel cell in the 111B goal, but it just was pushed away. Looks safely held in the back of the goal for red. (111B) dropping off more yellow fuel in their goal as 111C gets the white cell and a bunch more yellow in their goal. Both robots' scoring zones getting fairly full. 111B looking to go for a steal attempt. 30 seconds remain in the match. We have some defense, or counter defense, if you will, being played by 111C, keeping their fuel safe. Both robots getting ready to make their last second plays as the clock winds down. Three seconds left in the match. Looks like we are final. All right, our scoring team is going to work on tallying those points. And we have our scores for our first match of the day. Team 111B taking the win by a score of 68 to 19. Our field reset crew will be getting our field ready for the next match between 111.
So this is our fuel duel presentation for 111A, and this is the CAD drawing of our robot here, which is also on our shirts, which hopefully you picked up. They're very beautiful, if I do say so myself. So this is our drive base, and this is the current CAD for our drive base. So we chose the Mecanum drive base, and we started with a presentation by Harrison at the beginning of the year, which we all experienced. And we looked at the positive and negatives of all the bases, and we narrowed down the drive base to Mecanum because we decided to have a wide bot with mini CIM motors and two 4-inch wheels. And we decided the dimensions would be 25 by 30, and that's what it still is. And so we started creating our CAD, and now it's tangible and getting worked on in the shop currently. So this is our intake. This was the intake last week. So you can see kind of those are the rollers. The balls go in, and then it brings it up into the hopper, which we'll talk about a little bit later in the presentation. But with the simple roller design, the wheels spin and the wheels will shoot the balls into the robot. So kind of like with momentum, hopefully the balls will get into the hopper. Adamus ended up doing the intake. So there is a half hex shaft measuring 10.656 inches in length and a 2-inch diameter compliant wheels. And we have 10 of them across. And then one 775 motor. And then we have custom-made mounts to put the spinner thing, and there's 2 of those. And then we have our spacers to make sure that everything's uniform and works the best. And those are 1/2 inch, and there's 10 between the wheels. And then why we chose this design was it was easy to make and use, and they were the most effective in the prototype stage. We made a few different intake prototypes, and this one we determined to be the best. And we had no pre-made mounts. We made our own, and we decided to 3D print it. So those 2, well, you can really only see one side, but the one side, the black that's like kind of holding the rod, is actually 3D printed. So this is our hopper floor. As you can see, there are 6 rollers, and the rollers are on the bottom to make the balls move easily with less chance of a ball jam. And then the intake raises the balls to the floor like I talked about previously. The yellow things, they spin, and then they bring the ball up into the hopper, and it's done by a conveyor belt system like it's used in assembly lines, stuff like that. Because the intake is near the floor, but the hopper is a little bit higher because of the need to put a battery and the electronics below the hopper. So these are our hopper walls, and you can't really see it exactly, but it is slanted, but it's used to funnel balls to the center to make sure that there's no jams or any issue with the balls. And our hopper walls are actually expandable, which is something very unique about our bot, which allows for more balls to fit in, and the walls expand up, which leads to less trips going back and forth for balls, which then makes our cycles and our scoring quicker. So our outtake, we prototype many different options, but we use one motor currently, and it moves the ball from the hopper to the outside of the robot to score the points. And a vertical rack is mounted to the outtake plate to move it up. And like previously said, we use one motor, and currently we are working on the outtake actually, so we don't have a picture of it. And then we have our special fuel mechanism, and we chose a cascading lift. So we thought about many different ways to make the cascading lift and what special fuel mechanism to actually use. And we ended up choosing the cascading lift just because it is more precise and faster, although it did take more time and thought and CADing to build. We kind of used that a few years ago on one of our bots. And then what is a cascading lift? Just there are 3 stages in the cascading lift. So it starts compressed and then it goes up and then up. So there's like 3 different levels of height that are possible. And the stage will extend, and then the third will start to extend after. So it like takes steps to get to the highest. And the first and second stage are connected with chains. And then there's a spring to push up the third and last level. So it stays inside our frame perimeter before the match so that we can make the dimensions that we need to start the match. So it's kind of just after we make the dimensions, which are like required by the Fuel Duel game, then we have more freedom with that spring. And that is all I have for you guys today.
Looks like we're ready for our second match of the day. Red Alliance, good to go. Blue Alliance, good to go. Field, good to go. All right, thumbs up at the table. Drivers behind the lines in 3, 2, 1. D moving off towards their black fuel cell, unable to knock it down. 111A taking a little rest break, ready for teleop. In 3, 2, 1. And drivers are in control now. 111A quickly getting their black fuel cell off of their tower. Quickly deployed into their scoring zone. Looks like a part of their robot may have been left behind there as well. They'll have to take a quick look at that after the match. 111D. Looks like there's some intake movement there, but perhaps some robot issues. 111A taking advantage of the confusion, zipping around the field, knocking off fuel cells left and right, strafing to collect balls on the side fuel depot. The rack and pinion sends their balls straight into their scoring zone, and they are looking like they're in pretty good position. Plenty of time left in the match for 111D to get in control and make a game of it. A's nice hopper belted system, delivering balls quickly and efficiently into their scoring zone. They are loading up and sending another load of fuel into their scoring zone. Drive team is doing an excellent job showing off the power of their Mecanum drive. Seconds left in the match. 111D unfortunately disabled in the corner. 111A looks like they have made the most of their time, and that is the end of our match. Scores are in for match number 2. And we have 111A taking the game with a score of 69 points to 111D 0.
So this is our Fuel Duel presentation for 111A, and this is the
We're WildStang 11B, and this is our robotics presentation.
This is our robot for the Fuel Duel Challenge. On the bottom left corner of the picture, you can see the intake/outtake system. On the top right corner of the picture, you can see the arm. And finally, we are using 4 mini sim motors for the drive base.
This year, the mechanical building process began by dividing into groups to work on each mechanical aspect of the robot. Each group brainstormed ideas that they later implemented into the robot. The ideas were then tested, modified, and constantly improved until the robot reached its final form. Lastly, this year it was more difficult to construct our robot due to the very limited amount of team members in person this year.
So first, after the presentation from Harrison, we started with the Google Sheet to calculate what we would need in terms of things like size of wheels, space between wheels, and type of motors. And then next, the first rough prototype was made in our CAD program using that info. And then after testing like what would work and what wouldn't work, we made small adjustments in the CAD, such as moving the wheels closer together, adding an indent in the front of the robot for the intake, and then removing that indent later, and adding a set of Omni wheels on the front. We then used circular saw to cut frame pieces and used a router to add the axle holes. Then the drivetrain was assembled using drills, rivets, and a lot of brackets. And then later we added the wheel boxes and the belly pan. And after a few meetings, we added the electronics using zip ties.
Regarding intake, we used a similar design method to last year, except that we used zip ties on the rollers. Because intake is the first thing we created, the robot is based around the intake design. First, when the game begins, intake starts in an upward motion, pushes itself over, and rolls the bristles. When the buzzer sounds, intake starts, forcing it downwards. Zip ties then push balls into the hopper.
So starting off, the outtake drops the balls that intake collects. Once collected, balls reach outtake. They get stuck on a pool noodle. Next, the pool noodle spins in order to roll the balls out of the frame. In order to prevent balls from rolling out before intended, there's a small space between the pool noodle and the robot. Moving on, the goal of the hopper is to maximum ball storage. Incorporating the hopper was more difficult due to this year's smaller robot perimeter and our goal to be able to easy access the battery. So because the arm mechanism needs to stay seated within the required start perimeter, the original design and placement of the arm has changed due to other mechanisms of the robot. Our original prototype was made of Legos and was able to slide the fuel balls from the tower. It used to use sidearm pieces to maneuver up and over the tower, but the more recent cat arm mechanism is placed near the back of the robot and uses a claw-like arm to grip and grab fuel balls from the towers. So our process of design is done through Onshape, which allows us to continue working and editing our robot digitally before physically constructing it. So CAD has helped us a lot for prototyping and visualizing what our ideas will look like, but we've had a lot of trial and error to get the robot where it is now, and we've used the strategy of design, test, and tweak.
The goal of electrical was to make sure the wiring is up to code and consistent. The electrical team faced several challenges this year, the first challenge being teaching new recruits how to install wiring. The older team members worked with younger students, and relay competitions to assemble a robot were held for some hands-on practice. Additionally, at one point in the year, there were 5 robots between all sub-teams, so electronics were running low and more parts had to be ordered. Some physical challenges include an 8-motor limit and a smaller robot perimeter this year than last year. The motor limit made it difficult to design the robot, and the small perimeter created difficulties in fitting wire in the robot and designing components such as intake. It was also difficult to install wiring that accommodated for its mechanical aspects. For example, the electrical team had to constantly consult with mechanical in order to achieve this goal.
Our main goal in software is to create a renewable system of programs, each of which could be more used efficiently in a more complicated set of functions used to move the robot. We started by assigning certain subsystems to each member to code. Each member specialized in coding that subsystem. Eventually, we went from coding subsystems to entire automated programs. As most of our members were newbie programmers, men needed to teach us how to code mostly through demonstration. For autonomous, we needed to make the robot retrieve the black fuel cells from the side and center of the playing field by itself. First, we needed to code a program to deploy the intake so we could pick up the fuel cells. Next, we needed to code a program to raise the arm to obtain the black fuel cells because it was worth the most during autonomous. And finally, we needed to pick up the fuel cells on the field. The main challenge this year was getting the Robo Rio to upgrade to its latest firmware version.
On the field for match number 3, we have 111A and 111C. Drive teams ready? Field ready? Thumbs up at the table. Drivers behind the lines. Match starting in. There we go. 3, 2, 1, and autonomous. 111A ramming right into the side, knocking the black fuel cell off and out of the field of play. That will still count for points for them. No movement on the red side of the field, but we are getting ready for our teleoperated mode. Plenty of time to come back. Two minutes and 15 seconds left in our match here. 111A quickly trying to pick up the black fuel that they just knocked off. And that goes right into their scoring zone for 25 extra points. Quickly off to the middle of the field, disrupting our fuel depot. And that's on me. Black fuel off the tower, ready for collection and scoring. 111C in red, unfortunately unable to move. Our FTA is assisting on the issue. But 111A is not giving them any room for maneuvering here, taking up plenty of the fuel cells that are on the field. Their hopper is full, their door is open, and their fuel is coming out after a little bit of percussive maintenance there. That is one full looking scoring zone with 1 minute left to play. A drive team looking closely at their robot from a low position, unsure if they were seeing something mechanically or if they're just admiring the fruits of their labor. "30 seconds left, and it looks like both teams are satisfied staying put. The scoring group may be able to get a head start on submitting their numbers. That's going to be the end of match number 3. Scores are in for match number 3. Blue Alliance, Team 111A, putting up 90 points. 111C looking to get back in condition for their next match.
Hey everyone, this is the 111C final presentation. Our goals were to make a functioning robot that would allow us to effectively complete all the game's requirements. We did this through many stages of prototyping on CAD for each of our individual subsystems.
We use the ball elevator to get balls into the top of the hopper to make them stack better. It's driven by the same motor as intake to keep the motor count low. It folds out to save space inside the main body of the robot, and we deploy it using gas shocks.
The outtake was designed to be as simple as possible, as to not overuse the limited amount of motors or space. We ended up being able to achieve both of these goals by using a simple hatch to let the fuel out and making the storage tall, be able to have more fuel within it without taking up too much space. The motor we use for the hatch is a snowblower motor.
This is our drive base. We decided to use tank drive since we were the most familiar with it. It was the most stable and it seemed to work best with our design because we wanted to conserve our motors for other components such as the ball elevator and the outtake. And the drive base itself is 24.5 by 13.5 inches, and we're using 6 4-inch wheels and use 2 sim motors to power the whole thing.
This is our height fuel mechanism, and it's mounted on the top corner of the hopper, and it rotates up from its starting position so that it can reach above the starting height limit. It will reach up to both the 24-inch and 36-inch towers, and we use a bag motor to control the mechanism.
Our software is divided in 3 main parts, or subsystems. We broke our robot into 3 subsystems: the ball path, the drive, and high ball. And then for our autos, ahead of the time, we created a bunch of steps that we would compile into our final auto program. And we have multiple currently in process auto programs.
This is our strategy. We created 4 flow charts for our different strategies, and therefore, if we are winning or losing, which side the robots are on, the speed of the robots, and how much time is left in the game. The 2 most important strategies are shown here on the slides, and they are whether we are winning or losing and which side the robots are on.
And that's it. Thanks for listening.
All right, so through 3 matches, we've got some initial standings up here. Team 111A with 2 wins at the top of the leaderboard. 111B close behind and standing by on the field, looking to catch up. Meanwhile, Team 111C, I believe, and Team 111C is in 3rd, and Team 111D is tied with them down there, but very early on. All right, standing by on the field, we have Team 111B and D. Thumbs up from our head ref. Thumbs up from our field. Drivers, behind the lines. Starting in 3, 2, 1, autonomous. Both robots moving quickly and autonomous here. 111D deploying their ball grabbing mechanism. 111B on the other side deploying their forks and knocking the black ball off the tower. Little wiggle at the end there. Counting down to our teleoperated mode in 3, 2, 1, and we're off. Both teams moving quickly here. 111B looking to chase down their black fuel that they knocked off earlier. 111D knocking off next to their driver's station. quickly moving off towards the side fuel cells. Team 111D's wide intake helping them pick up as many balls as they can, as fast as they can. 111B has skewered a white fuel cell. We'll see if they're able to remove that and get it into their scoring zone. Both teams congregating near the middle of the field. 111B playing some defensive posturing, preventing 111D from approaching their scoring zone. Ooh! We have a part of the robot on the field, incidental contact, causing that to fall off. Hopefully that's a quick repair. That might be a little bit more of a repair for 111D here, but they still get their fuel scored. Pit crews might be taking notice right about now, getting themselves ready to repair some of these robots after the match. But in the meantime, drivers are working with what they have. Plenty of points are still scored for 111D. .30 seconds left in the match. 111B hoping to get a little bit of de-scoring. Hard contact there between both robots. A lot of metal on metal contact that we're hearing. 15 seconds left in the match. We will see what these robots are able to do as the match winds down to 5, 4, 3, 2, 1. Match number 4, a close one here. Team 111D winning with a score of 40-30. Both teams now getting their robots ready for their next match.
All right, so this is our fuel duel presentation. It's WildStang Ting Kong Long, sponsored by the Short Distance Break Frenzel family. All right, so starting out with our drive base. We decided our drive base to be an H drive because it is versatile and allows us to strafe left and right without turning. And while it may look like this has no flaws, there were a few design changes that we needed to go through before we got to our final results. So first of all, we are no longer using 6-inch diameter Omni wheels because we wanted to keep the hopper the lowest to the ground, and the middle wheel was kind of getting in the way. So we switched over to 2.5-inch diameter Omni wheels. And the middle wheel was also getting stuck at the raised parts of the arena floor, so we moved it back to help solve this issue. We need to, the middle wheel to be level with the other wheels or the driveways will not work. So this took quite a bit of time to get right, but I feel we managed to make sure it's nice and level with the other wheels. And then finally, one extra motor was added to the middle wheel to add more torque. And now on to our intake. So our intake took a lot of inspiration from last year's intake, which worked extremely well, except this time it only uses 2 tubes to feed the fuel cells into the hopper. The fuel cells roll on some 16-inch polycarbonate as the 2 tubes feed the fuel cells into our storage. The intake is also just as long as our robot, so we can maximize the amount of cells that can enter the hopper at once. It starts within the hopper and uses a motor to deploy it in front of our robot. And the intake uses only 2 motors, and it uses belts to transfer motion to the tubes.
Our hopper is the biggest part of our robot. It can hold around 20 fuel cells at a time. We want to hold a large amount of fuel cells before dumping them into our loading zone.
The hopper floor is on an angle so that the fuel cells come out the same way they come in. Because the floor is on an angle, this requires 0 motors specifically for the hopper for outtake. To keep the hopper lower to the ground, we need to use smaller wheels on the driveways. Because the intake is just as long as the hopper itself, it does not require an agitator.
Our high fuel design has 2 arms powered by 1 motor. When the motor is running, the arms will swing forward in unison and grab whatever is in front of them. It starts inside the robot connected to the hopper, but has a gas shock that will propel it upright once we start the match. The arms are long enough to grab both the low pillars and the high pillars, and it has a 10-to-1 gear ratio.
And finally, onto our descoring. This is kind of an idea that we kind of thought of alone, and basically, it pretty much takes the fuel cells out of the other team's loading zone. It was tough to work around with our robot constraints because your robot can only reach 10 inches outside the base. But if it works as intended, I think it will be very beneficial. The motor will be attached and will swing the arm to attempt to clear the fuel cells from the other team's loading zone. And it has a hook design so it can almost grab and hold the cells as it swings forward.
Can we get a round of applause for our field repair team? All right, on the field for our next match, we have teams 111B and 111A. Looks like we are good to go on the field, good to go with our drive teams. So let's get this on the road. Drivers behind the lines. Count it down. We've got 3, 2, 1. Both teams moving in autonomous. Team 111A successfully once more removing the black fuel from their tower. 111B matching them. Unfortunately, that did not bounce into their scoring zone, so it looks like our teams are tied coming out of autonomous. No bonuses awarded there, but the points are still on the board. Back into teleop we go. Both teams quickly picking up their black fuel that they worked so hard for in auto. 111A trying to knock off more effective fuel cells, while Team 111B is scoring what they have. There goes a large load of fuel into the Blue Alliance scoring zone, while Team 111B is taking off a white fuel cell for red. Quick movement from both teams on our field here. 111A disrupting the fuel in the middle of the field. That's going to be some congestion that both teams are going to have to work around. A lot of opportunities to intake lots of balls very quickly though, so that will help our teams in their offensive output. Looks like the intake from 111B flipped the ball into the 111A hopper. Nice little cooperation there from both teams. And the cooperation is off the table. 111B stealing balls out of the 111A scoring zone. Both teams playing some aggressive fuel duel. Lots of contact, lots of scoring. B looking to add on to their point total. 111A looking to do the same. As we come down 15 seconds left in our match, both teams looking to score any final fuel cells in their robot. With 5 seconds left, are there any more points we can get out? Yes, there are. Our scoring team looking to tally up. It looks to be a close match between our teams here. Thank you once again to Field Repair. We appreciate all you're doing to keep our competition flowing smoothly. After that match, we are now going to have a 5-minute field timeout to give our team some time to take a look at their robots, make sure everything is in tip-top condition, and also keep our field in tip-top condition as well. Scores for our last match are in. A high-scoring, very close match between our two teams. 111B taking the win with a score of 63 to 53. Drive teams are getting on the field for our next match. Let's take care of some introductions. On the Blue Alliance, we have 111D. A short break for them. Their robot looks like it is back at full functionality. On the red, we've got 111C. 111C. Thumbs up to me. All right, thumbs up from our head ref. Getting ready to get underway with match number 6. Drivers behind the lines. Counting down from 5, 4, 3, 2, 1. Autonomous mode, 111D quickly deploying. 111C doing the same. No black fuel knocked off in this autonomous period. Both teams are tied going into teleoperated. Two minutes, 15 seconds on the clock. Both teams getting ready to collect some more fuel cells. 111D, their intake is now deployed. 111C slowly creeping towards that black fuel. And the white fuel is off the short post for 111D. They are looking at a black fuel cell and a white fuel cell in short order here, lining up, and it is in their robot. C, their googly eyes are staring towards the scoring table menacingly, looking to collect some fuel and get in the way of 111D as well. Black fuel cell off the tall post for 111D. They now have 2 black fuel in their robot. That is going to be a whole lot of points if they can get them scored. And there they are, 2 black fuel cells in the Blue Alliance goal. 111C, I'm sure would like to get those removed to help their odds at winning this match. 111D is not slowing down though. They are coming in with another load of yellow fuel. But as they go to deploy their yellow fuel, the black fuel comes out of their goal. They are quickly getting that in control of their robot. It is there. They have white fuel in there as well. 30 seconds left in the match. 111D deploying. There is a lot of metal on metal contact going down there. Seems like both robots are okay. Ooh, that is some percussive defense being played there from 111C. Hearing some clicking noises from the robot. Hopefully they're both okay. 111D's H drive is certainly okay. They are doing some good strafing there, and that will take us to the end of our match. Results for match number 6 are in. 111D scoring 52 points, taking home the win. After the halfway point of our qualification matches, 3 teams are tied at the top of our standings with 4 points. Going to be a tight race to the finish. We are ready to get underway with match number 7. In red, we have team 111D. In blue, 111A. We've got a thumbs up on the field. Drivers behind the lines, getting ready to start in 3, 2, 1. 111A with their signature high-speed ram, getting the black fuel off the tower, and that is going to score them points. 111D, unfortunately not able to match. D has proven themselves capable of scoring lots of fuel though, so this match is far from over. Two minutes, 15 seconds left. 111D quickly knocking black fuel off of the goal next to their driver's station. Picking up the black fuel cell. 111A looking to intake the ball that they dropped off, but it is still sitting in the corner. That might be inaccessible to them. 111D carefully picking off the white fuel cell from their corner tower and dropping it carefully into their scoring zone. That's going to score them 10 points. D looking to intake the black fuel in the corner, but it looks like they're just going to make it inaccessible for both teams, especially with 111A's intake sitting at midfield. 111A, unfortunately, intakeless, looking to set up in a defensive posture, protect the lead that they do have at the moment. 111D, on the other hand, looking to stock up on fuel and get ready for a high-scoring dump. D getting caught on some fuel at midfield, but they are collecting more as they have finally run into 111A. This is going to be a battle for position as they look to drop their fuel off with 40 seconds left in the match. Good defense from 111A, chewing time off the clock. 111D is still going to have to find some way to get their fuel scored if they want to overcome the lead 111A put up in autonomous. 15 seconds left in our match. 111D hoping they have got some way to push their fuel into their goal. 5 seconds, they get it in! More fuel dropping into the scoring zone for red as time expires. Our scoring team will be tallying up the points, and they will tell us who has come out on top here. Excellent job to both teams. Scores are in for match number 7, and it is Team 111D with their last second fuel drop-off taking the win with 42 points to 111A's 37. We are getting started with our preparations for match number 8. Team 111B is going to be repping the blue. 111C, in true WildStang fashion, arriving just in the nick of time, repping the red. All right, we are green on the field. Drivers behind the lines. All right, autonomous mode has now begun. Team 111B, their scissor lift is deploying, approaching the black fuel. They have successfully nailed it, and that black fuel cell, I don't know if that counts. I will leave that decision up to the scoring table. Getting ready for teleoperated 111B with that black fuel sitting in their robot ready to score 111C. We will see if they are able to get moving. They better move quickly because 111B is looking to take their black fuel cell. That scissor lift is moving up. Fuel is up and rolling down. Successfully collected by Team 111B. They are looking to score their black fuel cell. They have now got 50 points scored in their goal between just 2 pieces of fuel. Excellent fuel efficiency. White fuel cells are falling from one tower. They are falling from the other tower, assuming shortly. And 111C is off. Their F-shaped stick is deployed, ready to knock any fuel off of a tower. Unfortunately, 111B has already taken care of all of them. Fuel is now everywhere in the field. 111B has disrupted the center fuel depot. 111C looking to take advantage of that before their opponent can. I see white fuel rolling across the middle of the field. 111B, a large point dump. 111C not far behind. Metal is rattling on the field as both of these teams are moving quickly to take up all the fuel. 20 seconds are left in our teleoperated period. 111C has a lot of fuel in their robot, but none of it is scored yet. There it goes. They now have points on the board. 111B looking to put in a couple extra fuel for good measure at the end here. Victory spins all around, and that is the end of match number 8. And after match number 8, we have a new high score for today. 111B with 96 points scored, taking home the win, rising in the rankings. 111C, 18 points. Getting ready for a final stretch of matches in the day. Every team only has 2 left to make their final push in the standings. Match number 9 is going to be between 111B and 111D. All right, our drive teams are ready. Our field is ready. Let's get match number 9 underway. Drivers behind the lines. And we have a false start on the offense. 5-yard penalty, repeat first down. All right, match number 9, part 2. We're green on the field, drivers behind the lines. And here we go. 111D is deployed, looking to grab the black fuel. They unfortunately miss. 111B, their scissor lift did not deploy. Very consistent to this point in autonomous. Let's see if they can get that fixed for teleoperated. These are our top 2 seeded teams at the moment, looking to solidify their lead in the standings. And there's the scissor lift for 111B, very quickly coming off of their robot. Oh! Both teams, now 111D, their grabbing mechanism is sideways, likely not going to get use out of that for the rest of this match. High speed impacts early on here. 145 left to go. Let's see how this all shakes out here. And let's hope that it's only shaking out and not shaking off. 111D, that is held on with a wire and a dream at the moment. Both teams getting their first fuel cells scored of the match. 1 minute into teleoperated. But one of the 111B fuel cells scored is black, so that is going to be some bonus points for them. The other black fuel cell I cannot see at the moment. The black fuel has come out of the 111B scoring zone. 111D looking to grab that up and take advantage of it for themselves. They have it secured in their robot, and it is in their scoring zone. That is a massive point swing for the Blue Alliance here. 111B is hung up at midfield. They may or may not be able to make up for that loss. 30 seconds left in our match. 111D is adding on to their lead. With 10 seconds left, this may be the final state of our match. 111D looking to score some more points right at the end here. And that will be it for match number 9. All right, we have our scores in for match number 9. A technical foul was assessed to Team 111D for violating the scoring zone of the Red Alliance with their frame perimeter. However, they do still walk away with a 48-13 point win.
It is our greatest pleasure today to present to you a new app, an app that is designed to deal with a sleep epidemic that has been causing great harm to our nation.
Did you know that 45% of adolescents and 33% of adults don't get enough sleep? Clearly, our society struggles to get sufficient sleep, and this has consequences. Poor sleep has been found to decrease academic performance. Also, lack of sleep costs us $411 billion every year.
So, how do we combat the problem of sleep? Our solution is a free app designed for all ages. Unlike our competitors, our app is designed to be used before bed, recommending the user with low intensity and personalized exercises. Our app also utilizes gamification and in-game currency to further engage the user.
Some aspects of the app will include using darker colors and high contrast so it is accessible as well as easier on the eyes. Using an in-app currency of Z's, you can purchase different planet themes and pajamas for your avatar. Sleeper Size also allows for you to connect and compare your progress with your friends. You can see your progress looking at the progress bar in the app.
We'll have features that will customize the way your avatar interacts with the app environment using the Z's. You'll earn your Z's based on your sleep length and quality. You'll also be able to change what routine you do before bed.
So how is the gamification of exercise going to improve your sleep? To answer this, we have to understand the link between physical activity and sleep. Light exercises such as yoga and stretching have been proven to improve sleep quality. So how many people would use our app? We surveyed our community and found that 72% of participants have significant interest in our app.
One of the biggest advantages of our app is that it's unique. On the App Store, there are many apps that are built on one or two of the features. For example, there are apps that promote yoga like Down Dog, but there are no apps which combine all these features and gamification, which is why we can guarantee our app a success.
Our hope is to help people of all walks of life experience better sleep and overall health. So we ask for you to try our app once it comes to the App Store. Thank you for listening.
So our innovation is Sleeper Size, and our motto is applying exercise for better sleep. A common problem we identified among Americans is a sedentary lifestyle, which has been found to negatively affect sleep and leads to worsening physical and mental health. We also found some data that supports this, with 45% of adolescents not getting sufficient sleep, 33% of adults not getting enough sleep, and anxiety and depression being linked to sleep disruption. Our solution to this problem is Sleeper Size, the application that improves sleep with personalized exercises before bed. We also surveyed a couple of different stakeholders. According to a survey of healthcare workers, 92% felt the app could be beneficial for themselves and their patients. And in a survey of consumers, 60% said they would actually use the app.
Sleeper Size is the only app of its kind. There are apps that share features with it, but Sleeper Size brings everything together. Sleep monitoring, exercise, meditation, individualism, and more. Sleeper Size will be implemented through recommendation by healthcare workers, use in education, and availability to the general public. The estimated cost could reach $100,000 to $150,000. However, it could be more due to the gamification and exercise library aspects. We're expecting our app to be funded by ad revenue. We could also partner with colleges or companies such as Sleep Number and have them sponsor it to benefit both parties. The degree of impact can be measured through better sleep, more REM sleep, and reduced time needed to fall asleep. The volume of impact can be measured by seeing how many people it is available to, how many have downloaded the app, and how many actively use it. Finally, the initial impact can be measured by how many people download the app, while the overall impact can be found with the amount of users and the amount of usage.
Next, we will discuss the design. Sleeper Size caters to the specific users' wants and needs, making it accessible for everyone. Here's our design as seen in the other presentation as well. It is created to be accessible to everyone, which means making it available for the disabled population in our app's future, and it will be clean and easy to use, making it accessible for everyone of all ages. Our theory is that with exercise before bed, it will lead to better sleep. If the exercise is light, it lets your body know that it is time for bed, and with prolonged use, you will gain improved circadian rhythm, which allows for better quality and quantity of sleep. Thank you for helping us apply Sleeper Size to the market, and thank you for filling out the survey as well.
All right, we are ready to get underway with match number 10. On the Red Alliance, we have Team 111A. In blue, 111C. Our field is green. We are ready to get underway. Drivers behind the lines. Count it down. We've got 3 seconds, 2, 1, and autonomous. 111A that was very scary, but they've got the black fuel secured in their robot. Meanwhile, 111C has deployed their F mechanism to attempt to knock off the black fuel on the other side. They will still need to do some work on that in teleoperated. All right, drivers are in control. Black fuel and yellow fuel is in the 111A hopper. They've knocked off the white fuel cell on the opposite side of the field. That is out of the field of play and placed back in by our field crew. I saw something fly across the field. I'm not exactly sure what it was. There is some high-speed robot action going on. 111A deploying fuel into their goal. Their drivetrain is helping them out with getting them out of their hopper. That was quite an impact between the two teams. Hopefully all of their mechanisms are okay. I see a little bit of movement on the 111A intake. We will see if they're able to still acquire game pieces. 111C, in the meantime, they have black fuel, they have yellow fuel in their hopper. If they can get it into their scoring zone, they may be able to make up the scoring difference right now. 111A has 1 minute to prevent that scoring from happening. They're playing aggressive defense, just as they did in their previous match against 111D. Excellent driving from Red. Coming up on the 32nd point in our match, there are still no fuel cells in the Blue Alliance goal. 111C is not moving. They playing possum. "15 seconds left. There is still nothing in the Blue Alliance goal despite all of the intaking efforts from 111C. This time it looks like 111A's defense was up to the challenge, and that is going to be the end of our match. Scores are in for match number 10. 111A taking the win, 53-10. We're going to have a 5-minute field timeout after that last match now. Teams have some extra time to repair their robots, and our field crew has some extra time to repair the field.
Welcome to WildStang's 2021 game design presentation. We are excited to present our game this year, Terrestrial Extraction. You are exploring the deepest reaches inside Earth to find new resources and learn more about the planet. Using your exploration robots, explorers have to gather ore to be refined and collect gems to bring back to the surface for further studies. There's a 15-second autonomous period, followed by a 2-minute 15-second teleoperated period. The last 30 seconds, a buzzer will sound, marking the start of the endgame.
Let's go over some of the elements that make up terrestrial extraction. There are 3 zones to this game: the home base, the mine entrance, and the mine. Home base is the area closest to the driver's station on either side of the field. Home base is where the robots will start at the beginning of the game. There is a climbing platform located at one end of the home base, and at the other end, a refinery is located. This refinery is where the opposing alliance will score their ore. The mine entrance is the zone between the mine and home base. This area is where the lift is located, and where 3 pieces of ore per team, 9 per alliance, can be strategically placed. These pieces of ore can be placed anywhere in the zone. The mine is the center zone of the field. This is where the ore and gem game pieces are located. The ore zone is on one side of the mine, and the gem zone is on the other side of the mine. The ore zone is made up of a raised platform and a tape line surrounding the platform. The gem zone is made up of a raised circular platform with 6 stalagmites placed around it. The ore and gems can be collected in both teleoperated and autonomous modes.
There are 2 types of game pieces that the robots can interact with: ore and gems. The ore game piece is a 10-inch diameter ball, and it will be made out of rigid material that is not compressible. Ore is collected from the left side of the mine. The area is made up of 2 sections: a raised platform and a tape line on the floor in front of the raised platform. The raised platform is 24 inches off the ground and will hold 29 ore pieces. The tape line is 32 inches in front of the raised platform, with 23 pieces situated along the center of the tape. Ore is worth 1 point when deposited into the refinery during teleoperated play, and 2 points when deposited into the refinery in autonomous play. Once scored, the ore will return back to the field, making ore supplies effectively infinite.
The gem game piece is an octahedron shape with 10 inches on the equilateral edges. The gem game piece is also not compressible. In the center of the arena, a large raised circle that is 85 inches in diameter, 4 inches off the ground, and surrounded by 6 stalagmites holds 19 gems. The stalagmites are 24 inches in diameter at the base and are 72 inches tall. Gems are worth 5 points and are scored on the lift. Gems are scored at the end of the match. They can also be descored by the opposing alliance when the lift is in the lowered state. When the lift is in the raised state, the gems cannot be scored or descored.
Along with having 2 different game pieces to interact with, there are 2 different scoring zones: the lift and the refinery. Those are where the gems and ore will be scored respectively. Another field element that the robots will interact with is the climbing platform. The refinery is a square with a 45-degree cut out of the exposed side, making 3 exposed faces that are 40 inches in length each. The ore is scored in an area that is set at 36 inches tall and is sloped backwards, making 3 goals. In front of the refinery, there is a protected zone where robots are protected while depositing the ore and cannot be hit by opposing robots. After the ore is scored, the ore is recycled back to the field. There is a chute on the side of the refinery that the ore will travel down and collect in a bin. The bin will only hold a certain number of ore before overflowing. The overflow of ore will spill back into the field of play. Human players can choose to dump the collected ore back onto the field.
The lift is a 40-inch by 40-inch square platform supported by 4 chains. The lift is raised 12 inches off the ground when lowered and 36 inches off the ground when raised. The lift takes 5 seconds to raise and 5 seconds to lower. At any point in the game, the lift can be activated remotely using the lift switch, and any gems on the lift will be safe until the lift is lowered again. Gems can only be placed on the lift when the lift is down, and can be descored by the opposing team when the lift is down. The lift switch is where the lift is raised and lowered. The lift switch is a brake beam optic sensor embedded into the wall of the refinery. To activate the lift switch, some part of the robot will have to break the sensor. The robot that is moving the lift will have to engage the lift switch during lift travel. If the robot disengages with the lift switch before the lift is completely down or up, the lift will go to the previous state. The climbing platform is a raised platform that is a similar shape as the refinery, but 2 of the sides are 40 inches and the other side is 30 inches. The platform is 32 inches off the ground.
The game is broken up into 3 periods: autonomous, teleoperated, and endgame. Autonomous is the first 15 seconds of the match. Robots will begin autonomous, touching the outer wall by their driver station. Robots will then drive forward to enter the mine and fully cross the mine entrance line. Bonus points will be awarded to each robot that achieves this. Robots will try to pick up ore either along the way from the floor, placed in the mine entrance area, or in the ore zone. Robots will then try to score more ore in the refinery. Ore scored in autonomous will be worth twice as many points as normal.
After the autonomous period is over, the teleoperated period begins. Teleoperated period is the next 2 minutes and 15 seconds of the game, where robots will be human-controlled by their drivers. Robots will have to pick up gems from the gem zone and place them on the lift. Robots will have to maneuver the stalagmites to get into the gem area and be able to get up on the gem platform. Robots will have to activate the lift switch by interacting with a brake beam optical sensor embedded in the wall. Robots will have to collect ore from a raised platform and from the floor. Robots will have to deliver this ore to the refinery, which is a raised goal on the side of the refinery.
At 30 seconds to go in the teleoperated period, a buzzer will sound. This will denote the start of the endgame period. Robots will have to exit the mine, and each robot to do so will earn bonus points. Robots will also have the opportunity to climb on the climbing platform. Each robot to do so will earn additional bonus points.
All right, we are getting ready for our penultimate qualification match. Match number 11 of 12, teams 111D and 111C on the field. That does not look like a thumbs up. All right, our teams are ready to start. Drivers behind the lines. Let's start the autonomous countdown. All right, 15 seconds left for both of these teams to show their stuff. 111C spinning in circles, just missing the black fuel. 111D moved to the end of the field. They are lined up, but they are not going for the black fuel. So both of these teams still tied coming out of autonomous. Drivers in control. 111D retracted their ball picking mechanism. They lightly tapped the black fuel off the post. 111C matching them on the other side. Neither team in possession of the black fuel, though. 111C looking to change that. It appears that both of the black fuel is tucked nicely into the corner. They may be out of play, leaving both of these teams fighting only for the white fuel and the yellow. 111D does pick up one of the black fuel cells on the opposite side of the field. They are now picking up more yellow fuel and going for white. Lots of high-value fuel now safely locked away in the 111D hopper. 111C has done a lot of disruptive work here, but nothing in their hopper yet to show for it. The fuel depot in the middle of the field is now completely empty. A whole host of balls in the 111D hopper. They are ejecting them into their scoring zone. The black fuel has not come out yet, though. Those points are not on the board. 40 seconds left in teleop. 111D, another full hopper going back towards their scoring zone. 111C has some yellow fuel in their scoring zone, but now D has their black fuel in addition to a piece of white fuel sitting in there. That is going to be a sizable number of points for them. 111C, their status light is solid orange. That means they are not enabled at the moment. No movement is going to come from them unless they can change something in the last 5 seconds. One last fuel dump from 111D will end this qualification match. Can we get a round of applause for the two teams picking up after their last ranking match? Great job to both 111C and D. Excellent showings today. We are in the process of getting our scores ready for display. All right, rankings for match 11 are in. 111D put up 78 points in their final match. Congratulations. So as many of you know, First did not have in-person competitions this year, but there was an Infinite Recharge at-home event that occurred during the course of the season. It is important to note that Team 111 as a whole won the Industrial Design Award sponsored by General Motors for the Krypton division. So congratulations to the team for that accomplishment.
Hello, I'm Sarah, and we're 111 going to hand it off to Nick to talk a little bit about our robot.
Okay, so this is our drive base. We decided to use a West Coast drive base because we knew how to do it well. And while we thought about strafing, we didn't see need for it. Because the robot was fast, we decided to use pneumatic wheels so that we could grip the floor and use the maximum potential of them and not slide when we turn. We wanted to make sure that we'd be able to get to the rendezvous point. So we chose to have 6 of them so that there wouldn't be a dead zone, so that we wouldn't get stuck. For our gearboxes, we have 2 Falcons on each side. We decided to use them because they're faster and more powerful than other motors. And they already have the motor controllers and the encoders already inside of them. The gear ratio, we have an 8.9 to 1 gear ratio because it allows us to get across the field as quick as possible, maximizing the point-to-point acceleration between the trench and the loading station. And then the motors were originally in the middle, but we moved them to the back to allow the hopper to have space. And then for chain tensioning, we have a snail cam to tension the chain and allow the wheels to have low backlash. Now I'm going to give it to Nick to talk about the intake.
For our intake, we decided to go with the design that had 3 rollers that are all connected together to a 775 motor using effects belts. We decided to put a pivot point at the back roller and then support the front portion of the intake with gas shocks so that it could easily collapse in on itself and act as kind of a crumple zone for our robot to allow it to be really flexible while still maintaining the support that it needs. To start with the intake, to deploy our intake, we use gas shocks. And to talk about how we do that here is Sarah.
We use gas shocks to deploy our robot, and because it's a one-time deploy, we have to have a hurricane lash that we can spin out. So this innovative idea was rooted in the fact we couldn't add another motor to our robot due to PvP space constraints and our design choice against pneumatics. So as mentioned earlier, it's a one-time release. So out of starting configuration. So we just custom designed and 3D printed a hurricane latch. So by spinning the intake rollers, the latch unhooks and the gas shocks deploy and force the intake to fall down for daily use. So to talk a little bit about our hopper, I'm going to pass it to Nick.
So we decided to go with a design for our hopper that was motorized and had belts lining the floor and the sides of the hopper. The belts all go toward the back except for one of the sides. The reason that 2 of the sides go in opposite directions is to prevent any sort of jamming that may occur. For example, if 2 of the fuel cells were to go, or power cells were to go in at the same time, one would be pushed forward and one would be pulled back, preventing any damage and preventing any jamming and still guiding all of the power cells toward the shooter. We also made it so that our hopper was completely removable. And to talk about that, here is Nate.
We designed our hopper to be easy access for battery changes. So there are 2 pins on the front of the hopper that when removed, the hopper can be opened almost like a door or like a little hatch. And so that allows for easy access to the battery. And so it's quick changes in and out, as well as the entire hopper can be removed from bolts on the back, and it can be removed from the front, which gives us access to all the electronics, to the PDP, if anything were to go wrong. Next to talk about the shooter is going to be Nick.
This is our shooter. We chose to have a turret with a 300-degree range of motion because it allowed us to shoot from anywhere on the field. We have limelight sensors to help us find the target when we shoot. And so the way it works is that the turret spins from a belt that goes around the base of the turret that's powered by a bag motor. And the hood is the only thing that actually changes when shooting, meaning that the flywheel doesn't change speed. So the hood moves up and down to the position that we need it to be so that we can score. And the flywheel is powered by 2 775 motors to give us enough power. And then we have a bag motor to rotate the hood. We originally had a snowblower motor, but we decided it wasn't fast enough, so we switched it. And I'm going to give it to Sam to talk about software.
Almost all of the aiming in our 2020 system was done by the Limelight system. Horizontal aiming was done by tracking onto the target and pivoting it until it was in the exact center of the Limelight's image. Horizontal aiming was done by finding the correlation between the hood angle and the size of the target in the Limelight system and plotting a bunch of those samples onto a quadratic equation. So once we found that equation, we could plug in whatever size the target was and find out what angle the hood needed to be. So when we put those 2 together, we could, from any point in the field, center onto the target, then adjust the hood depending on our distance. We had 2 separate of those equations, one for when we couldn't get the inner fuel and one for when we could get the outer fuel. And we also implemented a brake system to prevent jamming up our motors. So if the turret turned too far to one side, it would just stop working until you turn to the other side. And here is Nick to talk about the climbing mechanism.
So for our climbing mechanism, we decided to go with a design that has 3 different stages, so we would still be able to go through the trench run while being able to extend up to the fullest height that we needed to go so that our hooks would reach over the bar of the climb. So what we do is we deploy our hooks using gas shocks, and then we drive so that both of the hooks are positioned over the top of the bar. Then we close our winch, so we turn a winch that is attached to belts to a certain point on our climbing mechanism that will close the climbing mechanism, clamping down on the top of the bar and lifting the robot off of the ground. We specifically designed the hooks so that they would clamp on and not move, so they had gripping material underneath and clamps on the outside so that it's not going to have any sort of range of motion. Our climb is insanely fast, and it can deploy once positioned correctly in only half a second and be up above the ground. And then to talk about software, here is Sam.
Our autonomous this year was pretty simple because most of the autonomous code was being used in Teleop with the aiming system, so really all we had to program was just some moving and then reusing that code from our Limelight aiming. When we started in the center, we would fire fuel, drive forward, pick up some more, and then fire it back out. When we started by the trench side, we would drive forward, pick up some fuel, and then fire all of them.
Thank you.
right, we are getting ready for our final match of the day here between teams 111A and 111B. And not only is this our final match of the day, both of these teams are currently tied in the rankings. So this will be a tie-breaking match for these two teams. No pressure. All right, we are green on the field. Drivers, behind the lines. Here we are, match number 12. 111A quickly gets the black fuel off of their post. 111B matching them on the other side and successfully capturing it in their robot. And they even get a little bit closer to the scoring zone too. Ready for our teleoperated mode. Drivers are ready at the controls. And we're off. 111B quickly looking to get that black fuel scored, and it's in. 111A has their black fuel in their hopper, but they go to take more yellow fuel out from the field instead. Some defense being played, preventing 111B from getting closer to any other fuel supply, and now they've got their black fuel scored. 111B grabbing a piece of white fuel, and now looking to pick up more from the sides. 111A, their hopper is full of yellow fuel. B has their white fuel scored. That is 35 points contained in their scoring zone. 111A, their door might be stuck. Their fuel cells are held up in their hopper, and it's up. They've dropped some fuel on the floor before they could get in position. And 111B now has a second piece of white fuel in their hopper. Getting that scored might be able to make the difference in this match. The 111A knows that well, and they're playing their best defense. They've been doing that all day. It looks like their intake might be a little bit out of position, so this might be their best way to keep the match close. Coming down here, we've got just under 40 seconds to play. 111A has made a move towards the center of the field. They picked up another piece of fuel. 111B took advantage of the opening. They go to score and they drop the white piece of fuel. They've recaptured it, but now they need to make it all the way back across the field to score. They have gotten there. The fuel is out of their robot and into the scoring zone. 111A did pick up another piece of white fuel. That's scored. 111B scores. Parts of these robots are on the field, but there is no tomorrow for these two teams. One last piece of fuel not scored, and that's going to be the end of our matches for today. Our scoring team is tallying up the points. It's going to be a close one here. All right, our scores are in. I mentioned before the match that this would be a tiebreaker in the rankings between these two teams. During the match, exceptionally close. We now know that only 1 point separated these two teams in their score. And it's the Red Alliance, 111A, taking the win by a score of 62 to 61. We are getting ready to post our final rankings, and we are going to take a quick field timeout to set up the awards for shortly after. All right, we've played 12 total matches, every team getting 6 plays. And it's all come down to this final ranking. Is going to be our first place team with 10 points, followed shortly by 111A, then B, then C. Congratulations to all of our teams. Fantastic effort on the field and some excellent games.
Hello, everybody. Whoa, Jesus, that's a little loud. Stand over here. Okay. So, this brief intermission is brought to you by WRSA, the WildStang Robotics Support Association. We have a little stand over here. We'll be doing a golf outing on July 31st. It's a fundraiser for the team. Help us put all these wonderful events on, all the volunteers. So it'll be on July 31st at Arlington Lakes. Hoping to have everyone out there. There's a QR code on the brochure over there, and you can also check the website. It'll be on there to sign up. Hoping to see a lot of you out there. We're also looking for volunteers to help for next year. We have a number of board members, kids are moving on, and we have ample opportunities for you to help and assist in whatever capacity you want to just help us organize some events, whatever your talents are, just sending emails out, those types of things. So hoping to see some of you out there and help us out, and worst comes to worst, let's get on the golf course and raise some money for the kids and have some fun. Thank you very much.